Hello class, I have put together this PowerPoint that will hopefully help you review for the exam coming up on this Friday. This PowerPoint is just going to go over how to pick out which variable you're going to eliminate and how to do it as simply as possible. So here we have a system of three equations, and we want to figure out if we want to eliminate x, y, or z. So let's look at each one in turn. So when we're looking at x's, this does not look like a variable that I would really want to eliminate. And the reason is because it's going to require lots of multiplication. Um, so like even if we want to um, eliminate x in the first two equations, all right, where we have 3x and 2x, that's not too difficult. We would just have to multiply that 3x times 2 to get 6x. So we'd multiply that top 3x by 2 to get 6x. And then we would multiply that middle 2x by negative 3 to get negative 6x. So positive 6x plus negative 6x will eliminate. But we'd have to multiply both of those equations by some number to get completely new equations. It would be really nice if we could just leave one of those equations alone, just leave it exactly as is. So let's see if we can do that with either y or with z. Right, when we look at y, we've got the same problem. There's no equation that we can just leave alone in any of these instances. All right, and if you want to see what it's like when it's different, let's take a look at the z's. All right, in the z's, um, we could eliminate the z's actually rather easily. So let's first just take a look at the top two equations. All right. I can leave that middle equation with that 3z completely alone. Don't have to do anything to that equation. And all I'd have to do is multiply that top equation with 1z in it by negative 3. So let's work that out. All right, so I kept that middle equation completely the same, and that top equation has been multiplied by negative 3 throughout. So now we have negative 9x minus 15y minus 3z is equal to negative 45. Now that negative 3z will now uh, cancel out with that positive 3z from that second equation. We'll see that when we add these two equations together. Right, we now have negative 7x minus 18y plus 0z. The z's have been eliminated, is equal to negative 51. So now we have one equation that now only has two variables. So let's go ahead and save that. We're going to we can use that later, but for now we're just going to set it aside. All right, so we got one equation with just x and y. Now we need to find another equation that also only has x and y. And when we're doing this, we have to use that third equation that we didn't use before. All right, we have to use this equation that I've just surrounded with red. So again, when using this equation, we only have to multiply one of the equations. All right, we're going to leave this third equation completely alone, and we'll multiply that top equation by negative 2. So let's see how that works out. I should have said multiplied by positive 2. Multiply that top equation by positive 2. Okay, so when we do that, that top equation becomes 6x plus 10y plus 2z is equal to 30. That bottom equation, negative 7x plus 2y minus 2z is equal to 3, that stays the same. We just add up our like terms. All right, so now we have negative 1x plus 12y plus 0z is equal to 33. So 0z, our z's have canceled out, and we now have our second equation. And we can solve for x and y now that we have these two equations. I'm not going to do that in this PowerPoint. I have uploaded onto Canvas another PowerPoint in which I do go step by step solving a system of equations completely. In this PowerPoint, I just want to help you guys to uh, uh, just pick up tips on how to figure out which variable you want to eliminate. So I'm going to do that with two more examples really briefly here. All right, so now we have a new system of equations. Let's see if we want to cancel out the z's again. Now, we actually do not want to cancel out the z's again because we'd always have to multiply both of the equations by some number. We can never leave any of the equations alone. So for example, um, we could multiply that 25z up top by -3 to get a -75z, and then we could multiply that 3z in the middle by 25 to get a positive 75z. And so then that -75z and that positive 75z will cancel each other out. But notice I would have to multiply both equations by a number then, and I don't want to do that. I want to be able to just leave one of these equations alone. So let's see if we can do that with y. No, we again cannot do that with y. All right, we would, just like with the z's, we would never have an equation that we can just leave alone. All right, what about with the x's? Now these are big numbers, but we can clearly see that we can always leave at least one equation alone while trying to eliminate x, because each one of these are called coefficients, these numbers before x. Each one of them is a multiple of 51. So for example, we could just leave that middle equation alone, just multiply it by 1, and multiply the bottom equation by 3. All right, if we did that, we would have 153x plus -153x. So those x's would cancel out. So that's one way to generate a new equation while letting that middle original equation alone, just multiplying it by 1. All right, so it's just less math that's required. Now, when we're trying to get our second new equation, all right, we're going to have to use that top equation because we didn't use it the first time around. So when we're trying to do that, we're actually going to leave that top equation alone. We're going to multiply it by 1. And then just multiply that bottom equation by 2 this time. So then you'd have 102x plus -102x. So again, the x's would cancel out. And we could do it with relatively little math because we didn't have to touch that top equation at all. So always look for a variable where you can cancel it out easily and not have to be multiplying all these equations by some non-one number. All right, let's look at one more example. All right, so I got new numbers. Now when we're looking at the x's are not going to be the way that we want to go. All right, that looks complicated. I have to be multiplying those equations by relatively large numbers. The z's are also no good. All right, again, there's no way I can just leave one of the equations alone. Right. With the y's though, we actually can eliminate y while leaving one of the equations alone.